I'm Amy Henson from Colorado State University Extension's San Luis Valley 4-H Robotics program. In this video in the Teaching Challenge-based robotics series, we're going to explain the Amazing Challenge. In this challenge, which was developed by our friends at RoboRAVE International, teams build a robot that can navigate an elevated maze composed of 45, 90, and 135 degree turns. This challenge can be run with one or more teams.
The Amazing Challenge requires very few supplies. To construct your maze, use 1 by 10-inch boards or shelving, which you'll cut to various lengths from 18 to 48 inches. These pieces will be used to form the maze straightaways as well as the 90-degree turns. To form the other turns, you'll need to cut square pieces of board. Then cut these pieces diagonally from corner to corner to form right triangles. These can be combined with the straightaways to make 45 and 135-degree turns. Once you have all of your pieces cut, you can arrange the boards to make a maze with various 45, 90, and 135-degree turns, both to the left and to the right. The beauty of this setup is that you can use these pieces to create a large variety of maze lengths and difficulty levels. For younger groups, use 5 straightaways and 4 turns, and increase the difficulty for older kids up to 7 straightaways and 6 turns. Once your course is built, you're ready to secure the maze together using duct tape. You can also use additional tape at the end of each 90-degree turn as well as each straightaway to signal completion of that section. This will help you with scoring. Once you're done taping the maze together, use permanent marker to write in the point values for completing each section of the maze. Each straightaway should be worth 50 points and each turn should be worth 100. I like to make the points cumulative as we go along the maze, so I'd start with 50, go up to 150, 200, 300, and so on. Put one last piece of tape at the beginning of your track and label it Start. Once you've done this, your track is ready to go. Using the elevated track is ideal, as you can tell when a team goes off of the board. If you don't have access to these materials, however, you can also just tape down a track using painter's tape on any floor material. This challenge is a wonderful introduction to making precision turns without use of any external sensors. It's a good introductory challenge for teams as it requires limited programming knowledge. That doesn't mean it's easy though. This challenge teaches teams that precision is important, from how they set up their robot on the track to the exact motor rotations they program for each straightaway and turn. Every error they make will be cumulative and make achieving their goal of reaching the end of the maze more challenging. Once teams have reached the end of the maze, they can work on improving the time in which it takes them to complete it. I run this challenge in approximately 3 hours. The first 2.5 hours are for kids to design, build, program, and test their robots, and the last 30 minutes are used for completing scored runs. For the build portion of the day, I let kids use any of the motors and standard Lego parts in their kit, but I don't allow them to use any of the external sensors. Teams are encouraged to program and test throughout the build time. Once teams are able to complete the entire maze, they should focus on increasing the speed at which they can complete it by increasing motor power or adding gearing. After building and testing are complete, you're ready for teams to compete. Each team should get a minimum of 2 timed runs through the maze. For each run, time the run using a stopwatch or countdown timer. Teams should get up to 3 minutes to complete the challenge. Teams get scored on the furthest distance they complete in that time period. Each straightaway is worth 50 points and each turn is worth 100. Use the pre-tape markers to determine if a team has cleared a straightaway or turn. If a team goes off the board during the 3-minute time frame, they can reset their robot at the start of the course and run the program again. Once the team reaches the end of the maze, the clock is stopped. The team receives additional points for each second remaining on the clock. There's a downloadable chart to help you calculate the seconds remaining easily. To assist with timing, I like to add a water bottle to the end of the course. The clock is stopped when the robot hits this bottle. Once all teams have completed the designated number of runs, you can decide how you want to determine your winner. You can award this based on the highest point run of each team, or you can combine their points from all of the runs and go by the overall highest total combined score. If you are only working with one team, just have them continuously try to improve their time and accuracy at navigating the maze, and if time permits, add additional turns and straightaways to increase the difficulty. If your teams enjoyed this challenge, consider entering this event at your local RoboRAVE competition. Visit robokirky.org to find the competition nearest to you and to download the complete competition rules.
That's it for the amazing challenge. Thanks for watching, and remember that you can download all of the challenge directions and a bunch of related resources on our website.